welcome to the Tackling Overheating in Homes event. So I think without further ado, I'm going to hand over to Polly Turton from Arup. Thank you, Polly.
Okay, good morning everyone. It's great to be here in Cardiff. And apologies in advance for what may seem a very London-centric presentation, but I'd like to think that the methodology and the approach we've taken in our study for London is applicable for other cities in the UK, but also internationally, and I'll touch on that towards the end of my presentation. Before I start, all the outputs from this project are available on the Arup website, and I've included the web links there. They haven't come out perfectly, so I'll make sure they get sent out with the notes from this meeting if you'd like to find out more about the work. So I'm just going to talk to you over the next, 20 minutes or so about the background context for the project, our definition of urban heat risk and why it's increasing, the project partners we worked with on this piece of work, an overview of the methodology, the inputs, the outputs, and then most importantly, who is most vulnerable to urban heat risk and what are some of the approaches we might take to reduce those risks in cities and homes. There's also lots of interesting work going on at the moment in this field, which I'll touch on, and you might be interested to follow up on some of those projects yourselves. So, apologies, it's a bit squashed, but that's London. And what this image shows is how many times nighttime temperatures in London remained above 19 degrees Celsius. So that means things didn't cool down at night time during that summer 2003 heat wave in the centre of London. So the red dots correspond with the most densely built up parts of London, and the green dots, or the yellow areas, correspond with the large areas of green space in London. So what this shows is in areas of central London where there's not much green space and there's lots of buildings, lots of concrete, lots of glass, things stay hotter than the rural land around London, and this can cause problems for buildings and people. And I suppose 2003 was seen as the trigger event by the Mayor of London at the time and public health officials in London. It was deemed an unacceptable event. There was an unacceptable level of discomfort, ill health and deaths in London, which you wouldn't expect for hot weather in this country. And I understand South Wales also experienced some of the brunt of that hot weather, as far as I understand, as well. Oh, excuse me. So, in addition to that trigger event, if you like, Arup had been involved in a number of different research projects, technical studies, policy work around understanding overheating in buildings and the built environment, ranging from CIBSE work back in the early 2000s to understanding London's urban heat island effect, and then a really good document we did for the London Climate Change Partnership and the South East of England and the East of England Climate Change Partnerships was Your Home in a Changing Climate, which looked at the three risks of overheating, flooding and water scarcity. Since this slide was put together, there's been a lot more interesting work been published. And if you are unfamiliar with the London Climate Change Partnerships website, there's some really good stuff on there about dealing with climate change risks in social housing stock. The last image, or the last front cover, was a small piece of work we actually did for the London Climate Change Partnership. And what that piece of work focused on was to see whether we could take a threshold-based approach to understanding the future risks from heat waves, such as the 2003 heat wave, in the same way that they had done for Thames Estuary 2100, which was looking at flood risk and sea level rise in the Thames Estuary, how that might affect London, and how you might design and manage that risk using a threshold-based approach. So you weren't designing flood barriers to kind of prevent a flood in 2100, but you would kind of use science and engineering techniques to kind of keep an eye on that risk as it increased and increase your defences accordingly. And so we were trying to sort of see if that was an appropriate way to look at heat risk. Could you sort of keep an eye on thresholds and temperatures and then take measures accordingly? What we found out quite quickly was hot weather is a bit more complex than flood risk, and it's not as easy as saying when things get to 25 degrees Celsius, things go wrong, or this risk will occur. It's based on a number of different factors, which I'll talk to you about now. So, urban heat risk. What we mean by urban heat risk is the risk from hot weather in cities. It's increasing because there's more and more people moving to cities. Cities are becoming more densely developed. There's more pressure on urban green spaces. And in big cities such as London, Birmingham and Manchester, you get the urban heat island effect, which we've just talked about. In addition, you have climate change projections, which means average temperatures are increasing, and as well as increases in averages, you get more extreme weather events as well at the upper end of, if you like, the probability curve. As the average shifts, so do the extremes. So, for example, what was a 1 in 20 event in 2003 is likely to become a 1 in 3 event by the 2050s, and a sort of 50-50 as likely as not sort of event by the end of the 21st century. Then you have the demographic change. So all these new people, all these new homes being built in our cities, but we're increasingly an ageing population, and there are specific physiological vulnerabilities, social considerations required to sort of accommodate an ageing population, as well as a number of under fives increasing. Both of those two population groups are potentially more at risk than others. So, London thought this was an important project, so did Arup. So we got some internal funding from Arup, and we pulled together a team of experts in their respective fields. So the Greater London Authority, the London Borough of Islington, London Climate Change Partnership, UCL, who'd done a lot of work in this area already. We then we got an additional chunk of money to work with the UK Space Agency to obtain satellite data and to bring that data and that analysis into our project. A bit like the Zero Carbon Hub have done recently, we did a huge literature review of all the relevant data that existed around urban heat risk in cities, in social housing. We then looked at the most relevant data. We then obtained that data. We focused in on the London Borough of Islington for reasons I'll describe it shortly. And then once we'd collated and analysed this data, we wanted to present it in a way which took it, if you like, outside of the realms of the climate scientists and the building physicists and the policy makers. We wanted to produce something which made sense to decision makers, you know, in a range of different sectors, a range of different levels of understanding. So here are some of the outputs at the city scale. The image on the left shows air temperatures in London, and this is data from UCL. And what this shows is it's obviously a lot hotter in London compared to the countryside around it. But also if you look at the yellow blobs, those correspond directly with large green spaces. So Hampstead Heath in the north of London, Richmond Park in the southwest. Then the image on the right, that's land surface temperature data, again obtained from satellite data. And it just highlights, again, the fact there's a direct correlation between land surface temperature and the presence or absence of green space. So important issues for sort of city scale planning. This image is of the All London Green Grid, which shows all of London's green spaces. And if you overlaid that with the previous images, there'd be an almost kind of direct match. And the red dot in the middle is the London Borough of Islington, which is right in the middle of London's urban heat island, and as you can see, there's not very much green space in Islington. In addition, Islington has a large proportion of social housing, amongst its housing stock and its built environment. And it also has a relatively old population. So we thought this was an interesting borough within London to look at for this project. And specifically, there were 2 wards in the south of the borough, which the London Borough of Islington itself had been doing some work on this issue and had been engaging with residents of social housing and older residents of social housing about their perceptions of hot weather and urban heat risk. So it was a happy coincidence that they had done that work, and it was an incredibly valuable input to the bigger project that we worked on together. So some of the outputs at the borough scale then were overlaying land surface temperature data with socioeconomic data, so census data and indices of multiple deprivation. That's the image on the left. Slightly unintuitively, the smaller the dot, the more deprivation there is. That's a kind of quirk of the techniques we used. And then on the right, it just shows the presence of local green space, so not the big parks and heaths, if you like, of London, but the small community gardens and pocket parks at the local scale. We also then took as a proxy the height of buildings. So what these images show are the presence of buildings over, I think it's 40 metres and 60 metres. So a 40-metre building might be a sort of 10-storey high building, and a 60-metre building sort of 15, 20 stories high. So again, we're not saying that every tall building is at more risk of overheating, but it was an interesting proxy to look at whether there's a higher risk in these particular neighbourhoods. So as a result of the analysis of the environmental data, the socioeconomic data, sort of city-scale data, and the more sort of local data, we developed what we have called the Triple Risk Index, and this was building upon an idea and work that the London Climate Change Partnership had been looking at for a couple of years. And essentially what this means is your risk, if you like, to urban heat is based upon where you are in the city, the characteristics of your building, and the characteristics of your characteristics, the characteristics of the people living in that building. So you could categorise people as high risk, medium risk, and low risk, depending on a number of factors. So a high risk case might be someone, 68 actually, probably very healthy 68-year-olds. 75, 80 is where I think physiologically the risk increases. Medium risk would be a young family with children under 5, living in a top floor flat of a house with no natural ventilation, no garden. And a low risk example would be, let's say, a young couple with no kids living in a very green and leafy suburb. So the high risk case perhaps is the one we might want to focus on. And then we tried to visualise these high-risk categories in a way which made it easy to understand. And once we'd identified the high-risk categories, we wanted to then identify practical solutions to reduce these risks. So we divided them into 4 groups: strategic and operational. So strategic would be sort of longer-term thinking, sort of prior to a heatwave event. Operational might be in the very sort of short time, weather forecast timescales of knowing there's one coming up this week. Who do you need to talk to? Who do you need to kind of make sure is okay during the hot weather event? And then physical and social strategy. So physical would involve kind of planning, design and engineering approaches. And the social approaches would be more the communication and the awareness raising measures. And then we put it all together in an infographic just to show how it all interrelates. So you're looking at the risk factors, the measures, all in one easy to understand diagram. So We were then interested in at what spatial scale you could implement these approaches to reduce urban heat risk. So city, borough, building, community, lots of those are interrelated and require a two-pronged approach or even a three-pronged approach. And then we put all the key messages in an easy-to-digest report, which is available on the ARUP website if you're interested. So in summary, the key messages were areas at most risk are those in the urban heat island with high density of people and buildings, often associated with high traffic, noise and air pollution, lack of trees and green spaces. The buildings at most risk, and I believe this is perhaps where the Zero Carbon Hub's work has most sort of direct relevance, are those in those high-risk areas, but with poor insulation, exposed to direct sunshine, highly glazed, often south-southwest facing, unshaded, limited natural ventilation, and little or no outdoor space. And the people at most risk, as we've talked about, are the very old, the very young, and those of existing physical and mental health conditions living in those high-risk areas and buildings. So I suppose what this begins to highlight is if you've got limited resources, let's say as a local authority or as a registered social landlord, can you perhaps focus on those properties and those residents who are in the high risk category in looking at housing allocations policies, in looking at the order in which you refurbish your housing stock, for example. And this has informed the London Borough of Islington's work going forwards, and I believe Islington now require overheating assessments to be undertaken for all new homes submitted for planning permission in the borough. So we came up with some key messages for specific groups of people. Urban heat risk is a feature in our spatial planning policies and our climate change adaptation strategy in London, but we need to continue to clarify and strengthen those messages, those policies. For public health professionals, obviously this was a very sort of hot weather focused study, but I think we need to sort of see hot weather as part of, if you like, a sort of seasonal health, seasonal management plan, and often the way that we look at fuel poverty and keeping homes warm in winter, depending on the measures you take to reduce those risks, you can either exacerbate or, if you like, reduce the risk of overheating in summer. So we really do need to think about this as a sort of seasonal, year-round issue in terms of how we design and manage our homes and neighbourhoods. And I think also this is, if you like, potentially a good news story. If local politicians kind of take up this issue, it can be seen as a positive thing. I think also for members of the public, just very practical public health advice, looking out for neighbours, looking out for elderly people in your block. It's not kind of highly technical, sort of scientific information. It's just keeping an eye out for people who might be more vulnerable during hot weather. So, in terms of further work, we're really interested to get more data and make it more usable for London. So there are web-based databases out there already, such as Shape and Giggle, and we are keen to make sure that the data that those resources obtain and present can be used, and similarly any data that we have obtained perhaps could feed into those. Ongoing monitoring and measurement of relevant data. Again, I think the more data we have on the sort of environmental factors and the socioeconomic factors, the better. And the idea of an urban heat risk index, which we've kind of, if you like, piloted in this project, we're developing it further, working with colleagues at University College London, King's College London, and we think this is a positive thing for London and its boroughs, but also for other cities in the UK and internationally. And the final bullet point there, I'm just going to talk to you about now. So as a result of the work we did last year, we are now looking at 2 other cities, New York and Shanghai, And the reason we're looking at 2 other cities was because Arup's a global firm, and we don't just work in the UK, but also they share similar characteristics in terms of being big cities with an ageing population which have experienced extreme hot weather events in the recent past. And also it gives us an opportunity to collect more data for London and look at London in more detail. So we've partnered up with our old friends UCL, and we're working with King's College London now, Climate UK through Juliet Daniels, some of you may know Juliet, Help Age International, because we thought the focus on the ageing population and older people in cities was a particularly interesting angle to take, and the Satellite Catapult, who are providing satellite data for those 3 cities. It's not a huge budget, but we've got additional funding from the Natural Environment Research Council, which is great, and also the Satellite Catapult are contributing some match funding as well to make sure we use some really good satellite data. So we'll keep you posted on that piece of work if you're interested. And this image just shows how North America and China have, using satellite imagery, the effects of the heat waves they've experienced in 2012 and 2011, where it was up to sort of 10 to 15 degrees warmer than usual or expected at that time. And this image here just shows, we're all the same really, whichever city we live in. We all share similar characteristics, interests, and desires for sort of high quality urban environments. Progress and insight so far on the Sharper project. We've just finished the literature review, identified relevant data sets, and we're just about to start the analysis. There's lots of really relevant and interesting work going on at the moment. And so I think the challenge is for us to provide sort of unique perspective on it and make the most useful contribution to a growing area of work. In a sense, we're mapping the landscape in all senses of the word. So mapping the cities, the collaborators, and the data that's out there. So if any of you have any contacts in Shanghai or New York, we'd be most interested to hear about them. And just got 2 more slides. I just wanted to highlight some other Arup work going on, and then some work of external partners and stakeholders which might be of interest. So Cities Alive is a piece of work we've published recently, looking at how we can build nature into cities at all scales, and that chimes very nicely with the idea of urban green space being a way to manage urban heat risk. The Cities Resilience Framework it's a tool used, developed by Arup and supported by the Rockefeller Foundation to assess how resilient your city is to a number of different influences, not just weather and climate related. The C40 Cities work, there are some interesting documents looking at benchmarking cities around the world using different data sets, and it covers both climate change mitigation and adaptation related measures. And for those of you who perhaps work with older people or who have a large amount of older people, if you like, on your list of tenants or stakeholders, ambient assisted living is a really nice think piece about how cities and buildings can be designed to improve the quality of life of older people and people living with disabilities. And then finally, these 4 projects or resources, if you haven't heard about the 100 Resilient Cities work already, that's a really useful website, and there's more and more cities joining that initiative by the month. And it's looking at common issues faced by cities around the world. So heat waves, flooding, droughts are some of those issues, and looking at what cities are doing about them. The Joseph Rowntree Foundation has published an amazing website called Climate Just, which means you can look at wherever you live in the UK, wherever you're interested in the UK, you can look at what your risks are to various climate risks, so flooding, heat waves, water scarcity, for example. Truck is a very interesting piece of work looking at large coastal cities around the world and how you can set out frameworks to improve decision makings in the context of extreme weather events. And then Awesome is a bit of a London-centric project, but again, the methodology could be quite relevant and useful for other cities. But it's looking at how air quality issues affect public health in cities, which has a link to hot weather events as well. So a bit of a whistle-stop tour, I suppose, through 2 projects we've been working on and some relevant work we think could be interesting for you in the context of housing in Wales. Yeah, hope that was okay. And over to Nicola.
Morning all, Nicola O'Connor from the Zero Carbon Hub. Thank you for the invitation to Cardiff to talk about our overheating project. Just to say we've got Rob Pannell in the audience as well, my managing director, and hopefully no heckling from Rob while we go through this. I'm assuming everyone's heard of the Hub, but just a little bit of background. So we were set up in 2008 to work towards how to make new homes more energy efficient, how to deliver on the zero carbon standard, which we're expecting to come into play in 2016. But more recently, we've started to look towards some of the issues and problems that can be experienced in very airtight, energy-efficient homes. And obviously one of them, we've just heard from Polly, is the problem of homes overheating. So a number of years ago, the Hub had done some work with the National House Building Council, and the goal there was to set out some of the causes of overheating and help work towards design guidance for architects and designers, specifically for new homes. And around a year and a half ago, we were approached by the Welsh Government and Constructing Excellence in Wales, as well as some of the Whitehall departments, to ask really, well, what comes next? Do we have a handle on how big the problem of overheating is for England and Wales? And do we really know what the policy is? Do we need to do more as a country to be prepared? And also, how is the sector already operating? So the Hub has been investigating this for the last year. I'm the project manager, and I actually work with one of Polly's ex-colleagues, Rachel Capon, who's worked on the climate change risk assessment and various other relevant projects. So we've been discussing with house builders, registered social landlords, architects, energy efficiency experts, building physicists, you name it, we've talked to everyone we can, just to try and find out what's going on in the sector. And so I'm just going to say a little bit about what we found today, a taster of some of the findings. Our first synthesis report will be published in June, but we do have these beautifully designed new evidence reviews, which were published on the 3rd of March at EcoBuild. And these are really part of our evidence base. They're designed to gather various pieces of research around key themes on the subject of overheating. So what are some of the impacts, both for businesses themselves, but also for the NHS or for the health sector more generally in terms of morbidity and mortality? Other effects resulting from losses of productivity if people's sleep is affected. We also looked at the risk mapping approaches, so the kind of things that Polly was describing that helps us really understand and target resources into areas where particular hotspots for overheating. We looked into how the current tools and methods available to assess at the development level or scheme level whether properties are likely to overheat or not. And also some of the more thematic issues around how we define overheating and the big problem is the fact that we don't really have an agreed standard or definition. And the fifth one, which I should really put up there, was looking at drivers of change. And I think this is particularly important to Wales, looking ahead to the future and how the climate and the ageing population and all these other things come together to perhaps raise the level of risk for the country. So in addition to that, we ran an overheating survey, had about 75 responses to that. I have also been interviewing people and now have got 33 hours worth of recording of me speaking, probably a bit too much during the interviews. And some of you in this room were involved in that, so thank you. And so, yes, we've just been trying to understand the big picture. And our report in June will present our first take on that. And the goal is really to say, well, if we can understand what's going on, the extent of overheating, how it might change in the future, and how prepared the industry already is to tackle it, then we might have a good sense of what kind of policy we would need on overheating, if any. So in terms of the extent of overheating, I should just say the project covers new build homes as well as existing homes, and that was something, a bit of a departure for the hub, because we'd previously focused very much on new build. And in terms of geographical scope, we cover England and Wales. As you might imagine, the data available, there's a lot more of it for England, and particularly for London and the South East, where the problem has been most prevalent. We are really, really keen to receive any monitoring data, and I think we'll be hearing from David shortly about that. Anybody with monitoring data from Welsh organisations, we'd love you forever if you were able to share that with us. But we have obviously asked a number of Welsh organisations of their experiences and how widespread they think the problem is. So for England, the consensus seems to be, and was reported by the Committee on Climate Change last year, that up to 20% of homes could already be overheating, even in relatively cool summers. So that figure is up to, and you know, that number causes a reaction in some people who just think that sounds really high. So what we mean there is they're overheating slightly, potentially slightly over thresholds and criteria set by, for example, SIBSE, the engineers' professional body. In terms of homes that are overheating to quite an extreme extent, where the health of the occupants may be jeopardised, we're probably talking a study, a very recent study by the BRE, which tried to estimate how many may be, reaching quite high temperatures. They did some modelling using the English Housing Condition Survey, and that came out as 0.5%. I think for Wales, it's much harder to say. The evidence base is thinner, but I think given the climate, we can expect the number to be relatively low. And indeed, when we asked Welsh organisations of their experience, what we were hearing was that there'd been the odd intermittent case of overheating, but generally people were experiencing problems of damp and flooding, and those things are much more at the forefront of people's minds. And I don't think that's a surprise, but I think something the Welsh Government and CE Wales are very interested in is how that picture might change over the future. And we've already got the climate change risk assessment for Wales, we've got the heat wave plan and the climate change strategy, and these are all pointing in the same direction, saying that essentially the risk of mortality is increasing quite significantly. Again, we heard from Polly that the frequency and intensity of heat waves will increase. We're obviously going to be seeing population growth and densification of cities. And I think for overheating and construction methods, again, and the drive towards energy efficiency is really something that we need to just be thinking all the time, is this going to be potentially creating a problem for us? So we'll be setting out, we're going to be doing a Welsh version of we're calling it for now the baseline report. This is a synthesis of our evidence gathering. and that will be available in June, so do look out for that. But just to say a little bit more for now on what we found from our interviews and our survey process. So as I said, what we're really trying to understand, in addition to kind of the big picture and what some of the research and the monitoring is telling us, companies themselves, do they think there's a risk? Are they integrating risk management into their business processes? And if not, why not? And if not, what would cause them to decide to do that? So I asked a lot of annoying questions. And just to say very quickly before we move on, that what we're talking about here is the internal temperatures within buildings, where those conditions become so warm and uncomfortable that people don't want to live there or don't enjoy living there. And in some cases, it may mean that they become ill and even awful consequences of people dying. And in England, that figure of heat-related mortality is currently estimated at 2,000 per year, rising to 7,000 per year by the 2050s. So that's quite a large number, and I personally was surprised by that. In Wales, the numbers are a lot lower, but still the trend is increasing risk of mortality. And Polly's covered some of the main risk factors and some of the reasons that buildings overheat related to the solar gains as well as the internal heat gains from appliances and people. And what we're just trying to understand is how do companies themselves think about this? Just to say quickly, our survey, 75 responses, and 22 of those were from organisations who operated in Wales. So it's not a huge number overall, but it gives us a good sense, a snapshot of what's going on. So when we asked about definitions, it was quite interesting that when we spoke to housing providers, so those directly involved in building or retrofitting homes, they think very much in terms of internal temperatures and comfort, whereas those involved in the health sector and heat wave planning, they're thinking in terms of external temperatures. And these things don't always map neatly in a nice straight line. And the way that buildings obviously modify the environment affects the extent to which rising temperatures will affect the people inside. So I think that's the first thing to say, that the built environment, the sector, is thinking about this in terms of thermal comfort, and the health sector, which perhaps suffering some of the consequences, is thinking about this in terms of excess heat. Companies also were having internally all kinds of different definitions, different ways of understanding overheating. Some were adopting CIBSE guidance, so CIBSE Guide A, which talks about bedrooms and living rooms staying within certain temperatures for less than 1% of the occupied hours. But hardly any organisation we spoke to was using the new way of thinking about overheating, which is the adaptive comfort model. And this takes account of the fact that people tend to adapt to they adapt their homes, quite obviously, they'll make changes, but also they adapt to the external environment and can withstand greater temperatures. But the thing that kept coming up again and again is we don't have an agreed standard that we use in England or Wales. And this is creating problems for house builders and housing associations in that they don't know whether they've done enough. They don't know what their liability is or what compliance looks like. So the question for our second phase of the project is, can we make a recommendation to the Welsh Government and to the government in Whitehall about what an agreed definition might look like? And it could be the case that actually that isn't the right way to go, and there's better ways to think about this in terms of reducing cooling loads. Just on the adaptive comfort model, was it yesterday? CIBSE is producing a new Guide A, so their environmental design guidance. Really, really good. This will incorporate that adaptive comfort model. And what it really is a kind of band of comfort. So Polly talked about vulnerable occupants. we can classify people as being in certain categories and narrow their comfort band as a result of that. And this is essentially the advice to the design community. So have a look out for that as well. We'd be happy to supply the link. So in asking our interviewees about how widespread they think the problem of overheating is, what we found in our survey, when we averaged everything out, we asked the question, how many of the residential properties you have responsibility for have had an overheating problem in the last 5 years? And the average came out at 16% of properties. That was a lot lower, again, in Wales. And in the interviews as well, again, we were just hearing examples, yes, we don't have a problem with overheating. We've got other issues. We're more concerned with the energy efficiency side and the problem of cold homes. When we asked, do you think that will change in the future? The answer was, we're not sure. We don't have enough information about this subject. Certainly for the vast majority of people I interviewed, this kind of anxiety about whether things might change in the future, whether they might get caught out, was something they were very concerned about. So we also asked companies how they go about assessing whether their own stock, any of the buildings are at particular risk, so trying to narrow down to these higher risk categories. And obviously we have the overheating check in SAP. And again, this is more on the new build side. And the vast majority of people are obviously carrying out their SAP assessment, but many of you may have experienced this, that essentially it is relatively easy to change the inputs of SAP so that you pass the test. And we haven't heard any examples so far of anybody failing SAP. And questions are being asked about whether changes are needed to that regime to give it more teeth. So most people were carrying out the standard SAP assessment and the overheating check. Interestingly, some house builders were doing what we see more on the commercial side, which is to do dynamic simulation modelling. So a much more detailed model of the property or the scheme to understand whether it's likely to overheat, whether the property falls within criteria. And as a result, you can start to tweak the design to make it come within any definition that you've set. So we were seeing people informally narrowing down to, I don't know if it was a scheme with 90 units, using the kind of risk factors Polly talked about and saying, well, for those 4, we're going to do this more detailed modelling on it, and then we can decide what the solutions are. So this kind of approach seems quite sensible, and companies are telling us they found that relatively cost-effective and helped them feel much more secure in the idea that they'd focused effort on those high-risk homes. But modelling isn't the panacea either, and we've talked about some of the external factors that can contribute to overheating or help lower it, from the urban heat island effect to the occupants themselves to green spaces. We also have seen lots of examples of overheating in corridors of apartment blocks. And at the moment, the models don't factor these in, and you're not required to do it. So there's a question about whether there's more we can do to help build protocols around modelling so you get to an answer that's more likely to be how the home is really experienced. And again, we'll be taking forward work on that in phase 2. In terms of internal processes as well, we're very interested in, well, somebody asked me at an event on Friday, well, why don't the architects just design this out? Why is it even a problem? Why should we even ask them to do anything? And from talking to architects in our process, they felt quite strongly that in contracts between their clients and themselves, specifying the need to tackle overheating and design for overheating was very important and empowered them to be able to take action in that area. And it made it much more likely that those designs would be seen through to the end. So when we asked, do you specify overheating requirements in your contracts, 54% said they didn't, 32% said they did, but when we asked more about it, it tended to be quite vague requirements. They weren't quantified in any way. So generally, some of the companies that we talked to felt very secure in their process. They were doing this and they were saying, we want to make sure our requirements are top notch. Just a couple more slides. Another indicator of how processes are going is we asked if you've had an overheating problem, as you've defined it, how did you find out you had a problem? And this is important because if we're waiting to the stage where people are complaining, it might already be quite a severe case of overheating with health effects. Or for businesses and organisations themselves, there's a reputational risk, a customer satisfaction issue on the line. So this was relatively positive in that around 60% of respondents were saying they were proactively asking their customers about their thermal comfort. Building managers were going around and checking, monitoring was taking place. But just over 40% said they found out essentially they had a problem from receiving complaints from customers. So that may not be an issue in itself if it's the odd isolated incident, but I guess if that is becoming more commonplace in time, it might be a problem. So just to kind of sum up the experience of going through those interviews in particular, so I spent an hour on the phone with 33 organisations and lots of other conversations with people less formally. And I think what we're seeing is just some really great examples of companies having a kind of end-to-end process that sees them understanding risk, narrowing down to the properties that look like they're most likely to have a problem, and then knowing what to do, knowing which solutions to put in at that stage, and then making sure those solutions are seen through to the end of the process. But I would say the majority had concerns about whether they were sufficiently prepared. And I think from the Hub's perspective, we're keen to see how maybe we can emulate that process of companies that are doing well to kind of spread that across the wider sector. So just lastly, again, the big question for our project and for phase 2 is if we wanted to support the sector in understanding their own level of risk and acting on it, what is it that sits around the wider framework? What more might need to be in building regulations or guidance? Or what do we need to do to change the modelling tools? Have we got enough skills? Are people modelling in the same way? And how do we enforce any of this? So I'd be really interested in people's views and whether you've had an issue yourself and whether you think the system essentially helped you to solve that. So I'll stop there. Thank you very much.
Really today I was asked to talk about the output of or some of the outputs from my doctoral research project. So just a little bit of background. This was one of a group of knowledge economy skills scholarship projects funded basically by the European Social Fund in collaboration with Cardiff Metropolitan University and in this case United Welsh Housing Association. I think there were 4 projects in total, two with Coastal Housing Group, one with United Welsh and one with Pembrokeshire. And the project was around ecological building practice, was the general kind of area. It's quite a broad field, needed to be narrowed down quite significantly, obviously, for a PhD project. So I spent the first few months of the project conducting a series of semi-structured interviews with some of the development staff at United Welsh, really trying to understand how they go about procuring newly built social housing, what are some of the issues they face on a daily basis, and where some of the gaps might be in terms of that process. And there were a number of interesting things came out of those interviews. Firstly, there was no real understanding of the need for adaptation to climate change. Most of the concerns that the development staff were engaged in were really to do with mitigation measures, largely driven by need to meet statutory requirements, building regulations, and the Code for Sustainable Homes requirement, which is, for anybody who is involved in social housing, will understand that that's part of the development quality standard that Welsh Government require for social housing that is funded through public finance. It was quite clear that there's a predominance of lightweight timber frame construction in relation to social housing. That was very much the preferred method of construction. There was quite clearly a lack of thought and engagement with designing external spaces around dwellings, which was another area of interest. And some of these ideas really led me as an architect to think that there was an area that needed to be thought about here. I've always been interested in the design of external space, how it relates to what goes on inside a building, or in this case inside a dwelling. And the kind of work I was doing at the time coincided with the publication of some interesting stuff about overheating in housing, the NHBC report, and some stuff written by Bill Gething, writing for what was then the Technology Strategy Board, talking about the need for adaptation strategies and designing for future climate. And so these were some of the kind of core ideas that set the research questions for my project. So thinking about climate change, how we need to address that in terms of an adaptation strategy. Looking at the way the temperatures are forecast to increase, this information is based on the UK climate impact projections, which I'm sure you will know are based around emission levels and about different degrees of probability. So looking at the central estimates, this is the kind of increase in temperatures that are forecast for South Wales, and also changes in levels of winter precipitation, which again is also quite interesting to think about. So raises a question: are we talking about a change in our environment to such an extent that we might be thinking about a climate similar to the south of France? I don't know, and I think that's one of the questions, that's one of the issues that most bogs us down when we're thinking about adaptation strategy. In a situation where we were thinking about those kind of climatic conditions, obviously in Mediterranean climates, people spend much more time living outdoors. They extend their living space to the areas immediately outside their homes and their businesses and their places of work. There's a whole wealth of literature that supports the idea of the importance of external space in relation to living accommodation. This report by CABE and the National Housing Federation has been around for quite a long time. I'm sure most of you will be familiar with that. And lots of the kind of wider benefits of external space are fairly widely accepted. So it was thinking about some of these, but particularly the ones related to a passive approach to summertime overheating and the potential for cooling that interested me, along with, as I say, with some of the wider benefits that might accompany that sort of approach. A more recent initiative, which I'm sure Polly will be aware of, the Greener Neighbourhoods campaign, again, funded by the National Housing Federation and supported by CABE, is about recognising some of these wider benefits of external space. And that's just a bit of a sort of cuttings board of things from their publication, and there in the middle you can see this idea of a 10% increase in green cover could have a beneficial effect in ameliorating predicted climate change in urban areas. So very much the kind of stuff that Polly's been talking about. So it raises the question to me, is there an opportunity to extend that kind of principle and look at suburbia and housing in general and in my particular case, social housing? So it's what we're really talking about is the idea of a functional landscape. So landscape that's just not green and pleasant and increases the amenity value, but actually has a function in terms of modifying the local microclimate and potentially affecting the internal living conditions. So my research questions were sort of formulated around this idea. So first of all, we needed to think about whether or not summertime overheating was actually an issue in recently built housing in South Wales. Wanted to try and find out how that situation might be affected by predicted climate change. I was specifically interested in how external surfaces in the immediate environment of a dwelling would react to changes in radiation that you could expect over the course of a daily diurnal pattern of radiation. I wanted to look at the intervention of tree shading. There's plenty of evidence that tree shading has been beneficial in terms of dealing with urban environments and the urban heat island, but could that be used in a more localised microclimatic situation? So could the shading provided by suburban garden trees provide a means of reducing the internal solar gain during summertime conditions, and could this modification result in an impact in the internal environment? So working with United Welsh, I selected a case study. This is a new build housing scheme that was built at Rasa, just north of Ebbw Vale, just located just north of the Heads of the Valleys Road. It was completed in 2010. I think the architects were Stride Triglawn Davis. I'm not sure if there's anyone here today from the office, but they very kindly supplied me with some design information, design drawings and specification. This particular unit was selected as being fairly typical. It was built to code level 3, lightweight timber framed building. It's actually a 6-person, 4-bedroom detached house, which isn't typical of a social house in South Wales, but the reason for selecting it was that there was some concern from my supervisory staff that at the beginning of my project that what I was setting out to look at may be difficult to illustrate, and that the margins might be quite small, and it was felt that a detached dwelling with a larger proportion of external wall might actually be more indicative of any particular effect that might be perceived. So the projected workflow, this is probably can't see this very well actually, but basically a number of stages in the project. First of all, looking at some overheating studies. So the intention was to use building performance simulation tools to build a virtual model of the dwelling and then test it using weather data files, the current weather data, to look at and see if there appears to be an issue now, and then to look at future weather scenarios based on the UK climate impact projections, and using weather data produced from the Prometheus project at Exeter University, where they've generated synthetic weather files which are designed to reflect predicted climate patterns in 2030, 2050 and 2080. And there are files available for the various emission levels and for different levels of probability. So that was to be the first part of the project. The second stage was to reflect really some work that was carried out in Cairo, looking at a similar situation, looking at the tree shading provided by urban trees in relation to a multi-occupancy apartment building, and the particular research team involved developed a technique of analysing microclimatic data using the ENVIMET model, which is a CFD mathematical model developed by Michael Bruce at the University of Mainz in Germany. That was used to understand some of the processes that happen on a very localized basis and to extract data from that stage 1 model to use it to modify standard weather files that could then be used in a second stage building performance simulation. In other words, trying to use bespoke weather files that would more accurately reflect what actually happens in the local vicinity of a building, because anybody who's been involved in building simulation work will know that standard weather data is usually based upon the nearest available source, which in this case would be Cardiff Airport, which of course is about 30 miles due south of this particular site. It's a different altitude above sea level, so the climatic conditions could actually be quite different. And so what this project is about is looking at really how local effects could have an impact, and it was important to try and address that in the research. So this was the virtual model using design builder, building performance software, zoned model, which the construction details are assigned to it. Together with, I think I've got a heckler somewhere. Together with activity profiles and occupancy schedules. And I ran through the building simulation using the current weather data, and as our previous speakers have talked about. We've talked about the need for defining what actually constitutes overheating. I had the same problem in my research, and I opted to use 3 different thresholds. Used the SIPSI threshold of 28 degrees Celsius and above. I used the WHO threshold, which is defined as 24 degrees Celsius, and that's designed to reflect increased vulnerability of an ageing population and to take account of increased vulnerability of infants and of people with compromised health situations. I also used the NHS heatwave plan figures, which there are 2 figures, one for 30 degrees Celsius, which is for daytime, and 15 degrees Celsius for nighttime. And I have to say that I tried to drill down and find out where those figures, how they originated, what evidence base there was to support them. And I singularly failed. I could not get anybody to talk to me at NHS about where those figures came from. So I have to say that the daytime figure seems excessively high and the nighttime figure seems excessively low. I paid less attention to that particular threshold. But this graph illustrates that current weather conditions, there's no significant evidence of overheating in the kitchen, dining and lounge zones. Taking the WHO threshold, there is quite an evidence of sort of almost 25% of occupied hours. There's evidence of that threshold being either met or exceeded. The number of occupied hours is the kind of standard way of reflecting overheating or reporting overheating, and it obviously relates to the periods of occupation. So I ran a whole series of these simulations for the different future weather scenarios. This particular one is for 2050 medium emissions scenario, based on the 50th percentile, I think, probability. It's using, for anybody who's interested, it's using the test reference year as a weather data source. And you can see by 2050, the model is showing that, there's now significant, over 20% overheating into the main living areas, the kitchen, dining and the lounge. World Health Organization threshold up to a third of occupied hours now appear to be overheating. So this is suggesting that this is likely to be a serious issue. So the next stage of the research was really looking at the microclimate, and as I say, I used Envimet, which requires you to build a three-dimensional gridded CFD model. I had two cases, a base case where I showed the dwelling in question in the centre. I duplicated it either side so that I'd got some relationship to a kind of standard estate type, social housing estate situation. Simplified the external design so that it had just two surfaces, grassed area which is shown in green, and concrete hard standing. So I've sort of indicated a parking drive area, pathway down the side of the dwelling, and a small patio area at the rear. The idea was to try and strip away some of the complexity of a standard garden and just look in simplistic terms so that we could get a better understanding of how surfaces respond to changes in environmental conditions. The test case was designed to show the intervention of tree planting. Went through a process of looking at different tree types that were suitable for use in a suburban situation. Obviously, there are issues to do with the size of the tree, the potential growth characteristics of the tree, the leaf spread, whether or not it's deciduous or evergreen. Selected a tree called a field maple, which is used in domestic and suburban areas as appropriate. And those were modelled, and the test case actually indicates two trees in each of the front gardens and a row of trees along the north elevation. I have to say the building faces due south, so this is a bay window arrangement on the front of the building. The Envimet model doesn't allow, it's quite simplified in terms of the building form. It has to be simplified into sort of rectilinear blocks. Also allows you to place, the model allows you to place sensors in the model at three-dimensional points. So I've marked them there on the front bay window, just below sill level. And the idea was to extract data from the simulation, which would tell me what the air conditions were like immediately outside an openable window, because what I wanted to do ultimately was to work out what effect the external microclimate was having on the air supply for natural ventilation. This is modelling the field maple trees. These trees were actually located in Cardiff, just off Ferry Road in Cardiff Bay. And I used a technique that's been developed by Pepper and McPherson and then developed by Shinzato and Duarte for working out the leaf area index and the leaf area distribution, which is required inputs for the Envimet model. The outputs from the simulation it's digital information which has to be interpreted using, in this case, using the Leonardo information visualization software. And what I did was take, in this particular case, horizontal sections across the site at 1.5 metres above ground level, which was designed to replicate what you would feel as an individual. It's around about eye level, 1.5 metres. But this particular case, a time slot, 2 o'clock in the afternoon. And I would comparing the ground cover only version, the baseline case, with the intervention of the field maple trees. So you can see just in a simple comparison of those two images, the effect. You can see the location of the trees, the colour coding. It's too small for you to see, but basically the cold colours represent cooler temperatures, and the warm colours represent warmer temperatures. So I looked at what was happening at a series of timescales. This is 7 o'clock in the morning. And to aid interpretation, I used Design Builder some path analysis tools to generate some images that would help me understand what was actually happening in with the Envimet output. So you can see at 7 o'clock in the morning, what's interesting there is that the length of the shadows created by the trees, and also the fact that the concrete hard standing is already beginning to warm up. Even at that time of the day, obviously a response to the fact that it's a different thermal mass. by 9 o'clock in the morning, that particular observation is more evident. We've also got an interesting occurrence here where there are the beginnings of hotspots on the in the near building zone at points where the geometry of the building reflect solar radiation from the vertical surfaces and create hotspots around the perimeter of the building. And this was interesting in terms of what effect that might have on the supply of ventilation air for natural ventilation. You can also see the tree shading on the concrete hard standing becomes more evident as the sun altitude increases. So by 12 o'clock, you see the effect that the shading between the buildings, between the blocks, has disappeared as sun height increases. Higher mean radiant temperatures experienced above the concrete hard standing, as you might expect. This effect of re-radiation from the faces of the building is much more evident now. You can see how the heat that's built up in the thermal mass of the external wall is affecting the cooling effect that you get from the grass, the grassed areas, and actually negating that in the near building zone. By 3 o'clock in the afternoon, an intensification, as you might expect, in the heat build-up. You can see the hot spots we've got, I think it's 6 to 7 degrees Kelvin. The EnviMet model output is in degrees Kelvin. A considerable increase in that particular occurrence. So, in addition to understanding what was happening to some of the external surfaces, the data from the two sensors that were placed outside the front bay window produced some data files that told me what was happening to the air temperatures, the dew points at that particular point, and that information could then be used to modify weather data so that I had some bespoke weather files that I could then use in the second stage modelling. So it's back to the design builder model that was put together for the overheating studies. Exactly the same model, and running natural ventilation simulations. And what I was particularly interested in was the ground floor living room, the lounge, and what effect on internal temperatures, natural ventilation, the intervention of the trees had. So this was using the CFD function in Design Builder. Those are horizontal cross sections through the lounge at floor level and at sill level, and looking at operative temperature contours for those spaces. And it's evident that the intervention of the trees achieves a cooling effect in the centre of the room of round about between 6 and 7 degrees Celsius, which is quite incredible. I thought it was quite incredible anyway. Obviously differences in the distribution at floor level and at sill level. The cool air coming in through the openable windows on the bay was seen to sort of flow across the room at low level, and the intervention of the trees actually seemed to affect the way that air flowed through the side window, which was actually on the leeward side of the property, which was a kind of unexpected finding. That's not very clear actually, but the two upper images are actually cross sections taken through the lounge and through the middle of the bay window, showing the distribution of operative temperatures. The lower two illustrations are contours, operative temperature contours at 3 o'clock in the afternoon, and you can see the difference in the penetration of cool air in the room is much more significant in the slide showing the intervention with the trees. Almost 50% of the room is cooled by the intervention of the trees. I also looked at the airflow, changes in the airflow patterns for the ventilation, and achieving slightly increased air flows through the bay window and through the side window. Not quite sure exactly what's happening there. I suspect that there's temperature differences in the immediate external environment created by the tree shading and probably by the evapotranspiration from the trees is actually creating some air turbulence in the local area. I also looked at the effect of the amounts of solar gain on the surfaces, on the mean radiant temperature of the surfaces of the bay window, the external surfaces of the bay window. Obviously windows are a weak point in the thermal envelope of the building, and so they're quite an area of interest really. So these two sets of images are taken from the test case and the base case, and you can see that in a situation without the tree shading, the heat build-up on that bay window arrangement with the angular sides is quite considerable throughout the day. Where tree shading is provided, it prevents the build-up of heat. So the benefit was quite significant. You got lower surface temperatures, both in terms of their extent of area covered, but also the amount of time that the higher temperatures are experienced. So that was quite a useful illustration. So just summarising really the outcomes from those exercises, looking at a reduction in outside air temperature of over 30% of the external air temperature by providing the tree shading, and reductions in the operative internal air temperatures of sort of over 25%, and a reduction in the solar gain to the external windows of over 50%. So the conclusions, what does this, what was kind of learned from this exercise? Tree shading provides lower temperatures both to the grassed areas and to the paved areas. It's more apparent in the areas where there's paving or hard surface. This is obviously related to the thermal mass, which changes more quickly in relation to changes in levels of insulation, and it retains those higher temperatures for longer periods of time. This, I think, could have implications of thinking about the way that we lay out site layouts and relative positions of hard standing in relation to access and in relation to the south-facing elevations. Tree shading is most effective in reducing mean and radiant temperatures in the mid-morning and mid-afternoon when the shadows are longer. Again, that's probably common sense when you think about it, but actually seeing the evidence base for it is quite interesting. The interaction of the building facade and the cooling effects of the landscape suggest that the supply of air for natural ventilation could be adversely affected by the configuration of the geometry of the external building, and I think that's got implications for the way we think about specifying materials immediately adjacent or below openable windows, or in the area of air intakes if we're still talking about mechanical ventilation. Thinking about the specification of materials generally in the near building zone and the effect that might have on internal temperatures. So we got a reduction, just to conclude, a reduction in external air temperatures greater than 30%, and also an indication that there is a positive impact on the internal comfort conditions. Reduction in solar gain of more than 50%, and reduction in internal maximum operative temperature of 6 degrees Celsius. Natural ventilation via openable windows appears to be enhanced by the trees. There's obviously scope for more work there. I wasn't really looking at the effects of evapotranspiration and the effects of air turbulence, which I think were playing a part. Obviously, there's more work to do in connection with that. There was evidence of increased airflow opposite to the primary wind, prevailing wind direction, which again relates to air turbulence. And tree shading generally is having a kind of cumulative effect on the reduction of radiant temperatures on the surface of the building. So thank you.
Right, thank you very much. 3 very interesting presentations there. So I hope you've got lots of questions for the panel. So we've got roving mics. Could you say who you are and where you're from, please? But I'm going to throw it open immediately. Thank you. One question, I think it's for the 3 of you, really. Feels as though, well, we are definitely on the back foot with all of this. Where is there any evidence of any of these issues being addressed very early on, pre-procurement stage?
Well, I think I haven't seen any sort of tangible evidence of new master plans or kind of new plots being developed where they've taken a proactive approach, but I haven't been looking specifically for that evidence recently. But I think what it highlights in general is it's not just the kind of the design of the house and the specification of the materials or the construction type of the house itself that contributes to this problem. And I think David's studies show that from a really kind of technical and considered point of view. I think the anecdotal evidence as well suggests that as well, and the kind of city scale mapping and analysis of data suggests that too. So I guess the short answer is probably not, but the longer answer is it kind of needs to be thought about right from strategic planning right down to detailed design for the site and the specification of materials and construction types.
Nicola?
Yeah, just to add to that, what's come up in discussions a number of times in workshops and sessions that the Hub has run is sometimes the modelling at the development level coming quite late on in the process, so that if you find an overheating, potential overheating issue, it's quite hard to then change designs to rectify that. And whether there's a case for doing more at the planning stage to at least formally or informally to assist people in thinking about some of these risk factors. So ideas of rules of thumb keep coming up, and we've seen evidence of developers kind of going through that process themselves informally and thinking about going through an almost checklist of things that they know to be problematic and then modifying designs as a result. But that practice seems to be relatively rare. Maybe people in the room can disagree with that. It'd be interesting to see.
I noticed from one of the Hub meetings I attended, listening to some of the people around the table, that certainly as far as high-rise buildings are concerned, top 2-3 floors potentially going to become uninhabitable under these conditions, and that obviously impacts on the returns, on the investment, the value of the asset itself.
Yeah.
And these are things that need to be considered up front if possible. Is anybody else looking at any of these issues at the planning stage?
Samuel Walsh Government. No, I mean I had a question for the panel, and that is that on significant developments, I can appreciate that the design team would do some of the modelling that Polly and Nicola talked about. But of course, for a lot of development work, it's driven by 2 things: planning policy and the extent to which planners are asking these questions, and then secondly, the stuff that I'm responsible for building regulations and whether Appendix P is fit for purpose. So I'm interested in whether the panel get a sense that planning departments are actively asking the sort of questions that would prompt developers to reflect that what's known in their designs.
I mean, is the London Borough of Islington, which happened to be our focus area for our study and our report, sort of independently, but also partly because of the work we've been doing with them, and because their location in central London, they are requiring new developments to undertake overheating assessments. And there's a sort of slightly alarming trend in London, which I think you're probably experiencing in bits of Cardiff, of lots of tall sort of residential developments, lots of glass, not overshadowed by other buildings, no mature trees, kind of providing any natural shading. And even in London, where air conditioning probably isn't necessary at all, maybe sort of specific points of the year, they're sealed with no openable windows. So it seems like there's a trend for buildings which are, creating problems for the future, not just environmentally or kind of for comfort and health reasons, but financially they might be quite difficult to let and sell in the future. And there's a lot of them on the books, as it were, going through planning at the moment. But Islington asks for those properties to undertake an overheating assessment, but other boroughs in London, as far as I understand, are not requiring those kinds of assessments.
I think it's useful maybe to look at what's happening in other cities that are currently warmer and have a history of warmer environment. For instance, Athens, where I attended a conference last year in Athens where Matt Santamoris made a really interesting presentation about the strategies that they're hoping to employ to tackle the issues around the urban heat island. Obviously, they're at a different point in the kind of exposure scale. They're starting out from a higher base point. Therefore, with increases in summer temperatures, it's going to become much more problematic, much more quickly for them. And so there's an urgency about the way that they're tackling this. And I know they're looking at work to develop design briefs as part of the planning system that relate to choice of materials, to landscape design, to other issues to strategic approaches to dealing with the urban heat island effect. And I can imagine that actually there could be some benefit in us looking in the UK generally at looking at some of the models that have been created in other areas, rather than trying to reinvent the wheel, as it were.
Yeah. What is the plan with your work, David? You've got to this point. Is that being built upon? Is that continuing with the study?
Well, it's obviously of interest to me in my post at the Welsh Government. It crosses over into Francois's area to a large degree. I'm very interested in the idea of performance driving our standards towards performance specification. So I'm kind of interested in that as a personal kind of crusade in my new post. But I mean, my work was literally part of a personal sort of research project. I should be looking to take that forward, but if anybody's interested in taking up some of those themes, I'd be interested to talk to them.
Sorry, could I ask another question? Other countries that have currently temperatures similar to those projected, I mean, is there anything that, any evidence, perhaps this, Nicola, your evidence review might pick this up. Is it simply a question of getting used to it? In other words, how are those countries coping at the moment with the sort of temperatures that we might see? David talked about different lifestyles and spending more time outdoors. Is it that simple or not?
I wish Rachel was here to answer this, because she's very interested in the acclimatisation side of things. My understanding of the evidence base is it's not cut and dried how long it will take for people to acclimatise, and obviously other countries have long dealt with having higher temperatures and have smaller windows and lots of thermal mass and courtyards in the centre of apartment blocks. But what we also see is they have a lot of air conditioning, and the question, I guess, for the UK is whether we want to see ourselves going down that route. And the policy framework at the moment is certainly all geared towards trying to avoid that. So indeed, the Appendix P test is you perform it assuming that the building isn't mechanically cooled. And indeed, you're asking about the planning side of things, Francois. I believe the GLA, the Greater London Authority, is in the process of commissioning work to baseline cooling demands, so that at the planning stage, developers will need to submit in their energy statements what the cooling demand for the building will be, And if it's higher than what would be expected for that type of property, then essentially that needs to be addressed at the planning stage. So, and again, all in the effort to try and kind of avoid having to resort to air conditioning, which again has a knock-on impact for microclimates and urban heat island.
I think a sort of shorter time scale of acclimatisation during hot weather events, people in general are more willing to be a bit warmer, and there's benefits obviously up to a certain point of warm weather. But if you're, let's say, unable to open a window, or you've got a fixed temperature which you can't control, people soon start to get quite fed up with that and frustrated. So I think there's a degree of control over your environment which is important in any degree of acclimatisation to warmer temperatures outside, which is an important consideration in the design of the internal environment.
I think there's an interest here about indoor air quality and the fact that, not only are we insulating our buildings to a greater extent, but we're making them more airtight. There is an evidence base to suggest that poorer indoor air quality it tends to result in people perceiving overheating at a lower level. It brings the threshold of people's perception down, because they're in a similar way they're less tolerant to increased temperatures when the air feels stuffy and unfresh, and this idea of adaptive comfort and being able to actually go and open a window or turn a radiator down, it actually there's almost like a placebo effect that comes into play. Just by the psychological effect of being able to do that makes people feel better.
Rob Panel, Zero Carbon Hub. Two things really. First of all, to comment on Francois's comment that acclimatisation seems to take place. 70,000 people died across Europe in 2003 because of the heat wave. So obviously they're not acclimatising enough to prevent mortality, and that would be my response. But my thinking is, my question particularly is around Paul Flynn, the MP for Newport, asked in House of Commons last week in response to the Hub's report, said, what is government doing about overheating? And the response came back from DEC, Department of Energy and Climate Change, saying, we're looking at SAP. I think that's a fair response. But I don't think that's enough. I think government have got to take this up more seriously if it is going to be seen an increase in mortality, and where people have to adjust buildings and designs, planting trees, or whatever. I think we've got to do a lot more from government in terms of determining the future of the risk of overheating and preventing it. So my question to the panel, what should government do in terms of driving the solutions to prevent high mortality risk, particularly in South Wales, which is where I live, so I'm particularly keen on the answer, and I'm getting older as well, but also across the whole of Wales. What should the government do in Wales to deal with this problem?
My view is quite simple. Should implement performance specification as part of building regulations.
You have some views on.
So I have a number of views on this. I think the first thing is we need an agreed definition of overheating that the industry works to, and that government needs to be involved in help setting that. But I also think the framework that we have in place, whether through planning or building regulations, needs to support and reward people for understanding the risk levels in their properties and putting in place solutions. Because if we are getting it right at the individual development level, that's going to have knock-on positive impacts for wider economic and health impacts for government. So yeah, really just supporting the industry and incentivising action in a positive way.
I guess my sort of suggestions would be about the availability of data and information, making it much more easily accessible and available, so planners, designers, house builders can access it and use it to inform their plans and designs. And also my second recommendation would be an emphasis on multifunctional green infrastructure. So as we've seen, that has benefits at the local scale and the city scale, but it also has other benefits around managing flood risk, which might be a bigger issue for some parts of South Wales at the moment than overheating. But if you look at it in a kind of joined up way, has multiple benefits.
There's some really interesting work that's been published recently from Heriot-Watt University. The particular paper is called Communicating Future Overheating Risks to Building Design Practitioners, and this is in connection with the development of their Low Carbon Futures tool, and basically they were involved in a series of workshops and interviews with practitioners from the industry, architects, building surveyors, people working for housing associations, looking at the way they engage with this problem, and the results are quite shocking, basically, because they looked at both residential and commercial sectors, and the results for the residential sector were basically it's not perceived as being, overheating isn't perceived as being a problem, and isn't perceived as being an issue that is anywhere near the top of the priority list in terms of what needs to be done on a day-to-day basis. So it's actually published in the Building Services Engineering Research and Technology Journal. I've got a reference if anybody wants to look at that. It talks about accessibility of information, and it was asking for feedback on a number of different ways of presenting information on overheating and climate change, and what practitioners felt would be the most appropriate level of information that they needed to respond to, and what was the best way of communicating that. And they were talking about the kind of colour-coded reference systems that we use for energy efficiency ratings and on washing machines and fridge freezers and homes. And that was identified as being a positive way of approaching.
If we can have a link to that report,
yeah, certainly.
Certainly with the work that the Hub's doing and the ongoing work that Arab is doing, different outcomes there, isn't it? Definitely, because this is an issue. I know we've got a few architects in the room. Are any of you prepared to share with us what either what you think about this whole issue or what you're actually doing or being asked to do in your work? Thank you.
Anthony Davis of Powell Dobson Architects. I think there is a market sort of issue there in regard to what the market wants, as you mentioned, in the high density residential market, particularly at the tops of the buildings. There's a desire for that sort of for that high quality end of the market. So in that sense, that there is this expectations, particularly in London, for the high specification products. So air conditioning in those sort of parts of the building are becoming quite normal. So and developers are just responding to statutory requirements in the market. So I think you've got to find ways of developing a product that's more sort of attractive to that market. I'd be interested to know what you think, what can be done.
Yeah, I mean, we're certainly seeing that occurring. I mean, the way the GLA is responding to that is through the adoption of the cooling hierarchy. So the starting assumption is that you design the building so that it can be passively cooled, working through the list to mechanical ventilation and seeing air conditioning as a last resort. I guess there's always going to be certain types of customers demanding certain types of homes, high-spec homes, and want air conditioning. But the question is, do we start to facilitate that becoming the norm or not? Do we keep working on prevention through good design and through providing adequate ventilation? And I think that's where we are at the moment.
I think it's a very good point you make. There's a certain market in London in particular, and I know it exists in other big cities in the UK and Wales. But I think it's about redefining what is a valuable and desirable property. I mean, for example, there was a commercial building Arup worked on in central London, actually in Islington, called the White Collar Factory. And the most radical thing about this new commercial building is it's made it possible to have openable windows in a high-spec office building in central London, and a very desirable proposition at that. And I think for certain residents, buyers, tenants of properties, having some kind of external space is an incredibly nice feature of an apartment. And so maybe sort of redefining what makes a luxury high-rise apartment rather than a sealed box, you know, where we can see is glass and a nice view. Maybe it's about kind of a new proposition of what is a high-end, valuable residential property, in the same way that we're trying to do that with commercial buildings.
Yeah. Yeah, well, I agree absolutely. I think there's an issue about perception there, perception of value and what is a desirable property. And air conditioning for a long time has been associated with kind of, you know, prestige kind of installation. It's about a different mindset, I think. I'm quite interested in one of the things that the SNAC, I think somebody made reference to the SNAC project, the Suburban Neighbourhoods Adaptation to Climate Change project, and one of the outcomes of that project, as I recall, was the idea of that we wouldn't actually come up with one solution. It'd actually be packages of solution in terms of suburban housing that were going to be appropriate, and I kind of latched onto that because it kind of fitted quite well with my research. But I think that's an interesting concept, because they looked at what measures people were prepared to do on their own basis. That was particularly looking at private housing rather than social housing, and looking at things that people perceived to add value to their property. Landscaping was one thing, actually, and tree planting, but there were various other things that people were prepared to do because it added value to their property, as well as having an impact in terms of dealing with potential overheating. So again, it's about, I think perception is quite an important aspect of that issue.
We did have another hand at the back. If you want to comment.
Sarah Byron, from Architecture Limited. Completely the other end of the scale. Social housing, flats, one-bed flats, usually single orientation, quite often on the ground floor. And one of the young ladies mentioned that the overheating element of SAP not having any teeth, and having. I'm an architect and a SAP assessor, and I sometimes work on both or either role on a project. And I've had quite serious arguments with clients and other architects when I say, look, this ground floor flat suffers from overheating, because I don't feel confident to tick the box to say the window can be left half open. Because if I was living in that flat on a ground floor, there's no way I would walk out of the flat or sleep overnight. And I've had architects sort of with long conversations to secure by design to say, oh, secure by design, say I can leave it open. And I've had arguments with housing associations saying, look, we're building them very tight, and I've written 2-3 page long letters, but I have no teeth. You know, the building regs just say, look at the air, consider the air quality. And I have no statutory regulation to say, look, we've got to do something with this. And you know, I've got some housing associations who accept mechanical ventilations, others will not look at mechanical ventilation. And it would be really useful down in the trenches on this very basic level to have something to say, look, there is an overheating risk, but it's very difficult for me to quantify, and because there's nothing for me to say you have to do something, it just gets ignored.
Interesting.
I absolutely identify with that point. I think nearly everybody we spoke to raised similar issues, and other examples were assumptions of keeping curtains closed all day. When the occupants are out, maybe fine, but when they're home in an evening, summer evening, is that going to happen? Somebody made a joke that we're not vampires, and Appendix P can't assume we are, which made me laugh. But yeah, I think there is a problem around the assumptions that we make and how well they match the reality of how people live in homes. And I think the assessing overheating risk review that I showed earlier, that goes into some of the issues around how we assume people live in terms of the number of occupants, the time they're at home, their window opening patterns, as David was saying, the extent to which people are willing to kind of solve the issue themselves. and do the models. Are they picking these up as well as they could? And I don't think we can ever get to a perfect 100% answer, but maybe we can do a bit better than we're doing at the moment.
Yeah, I mean, just on the security point of view and like leaving windows open, especially at night, you know, it is a big issue. And I'm not saying, you know, we can design it out completely, because there's always going to be issues with crime and noise and air pollution in cities until we come up with some magic solution. But maybe kind of simple designs for windows or attractive external, you know, some kind of design solution which could contribute to reducing that problem would be worth looking into.
Some mentioned looking at other countries and how they deal with it now.
Mm-hmm.
The most basic one is the shutter.
Yeah. And
So
also,
have you ever tried getting a shutter through a plan?
Through planning.
right, no, I haven't. Is it difficult?
So on the last scheme that's just on site now, I finally persuaded the Housing Association on the ground floor to have internal shutters, security shutters. So at least I know the ground floor people can leave their windows fully open and have ventilation and feel secure.
Yeah.
But it was hard back.
Really?
Yeah.
That's so surprising, isn't it? I mean, it's such a simple solution, isn't it, in some ways?
But maybe there are other SAP assessors who are happy to tick that box.
Yeah.
I think that's an issue in itself about how people adapt to change. Full stop. You know, changing their environment, but changing working practices, changing about perception of things. What's acceptable, what's not acceptable, what's appropriate in the UK climate that perhaps, you know, wouldn't have been thought of 20 years ago. You know, perhaps we need to have a major rethink about the way we design our buildings, and be prepared to look at precedents and ways of solving the problems that are already in existence and operational in lots of other countries. I don't see that as being rocket science, but I think that the more difficult part is actually persuading people to change and change their mindsets.
Francois, I don't usually like to put you on the spot, but as far as Welsh Government is concerned, and social housing particularly, where is all of this going? Where's policy going and building regs that are addressing this particular issue?
Well, I think what's important to the Welsh Government is an understanding of the risk to Wales, okay, and local areas. And if at the end of that it is concluded that Wales is low risk, what do we need to do via building regulations, planning guidance to keep it at that low risk? So it's very much fact-finding at the moment. But Rob said that DEC's solution is a review of Appendix P. Now, of course, we've got a tool. We've got the overheating tool in SAP. So I think, and quite rightly, when DEC say they're reviewing that, and we're part of the government group. DEC owns SAP, but we're part of the review group, is to look at what we got and whether or not that's working properly, and whether or not people are tweaking it to get through building regulations approval. So that's the starting point, is look at the tool we've got, make it sure it is effective, and whether it reflects, it's sophisticated enough to reflect the sort of scenarios that we think we're going to have to deal with, because SAP is a fairly simple tool. It's not a design tool, although it's used by some people as a design tool. You know, if you look at more sophisticated assessments, if you look at SBEM, for example, they already take into account things like overheating in a more sophisticated manner. So it may be that Appendix P isn't up to the job, I don't know. But it's what we've got, so that's where you should start. And then it's a question, that's why I asked the question about planning. Where does it sit on the planning sort of list of priorities? Because there is all sorts of connections to be made with it. Lady mentioned security. Well, I mean, there's cross-cutting issues here, which are all in the planning domain, in a sense. You know, we're going to review the building regulations to look at physical security, but that's a lot of locks and stuff like that. The actual the actual development itself, and whether opening ground floor windows a practicality, is something that you deal with at the planning level. You know, in conjunction, and the guidance is there, but it's connected also to trying to raise to raise awareness amongst planners of a connected topic of overheating, because there's an impact. So there's some joining up possibly to be done, but you know, I don't know whether that was a criticism of DEC, but I think where you start is you've got a tool, does it work? Is it up to the job now? Is it up to the job in the future?
Okay, Rob?
I'm interested in, one for Polly actually, particularly, and for David. I'm interested in hard surfaces externally. I think we get obsessed with the box, but I think we should look outside the box, literally, in terms of a building being a box. I'm particularly interested in transport and the desire in terms of inner cities where we just pave over anything, we put a car on it. And we saw on the graphics that David presented where the concrete driveway or tarmac driveway was immediately heating up at 7 o'clock, 8 o'clock and 9 o'clock in the morning. Should planning do more, and it backs up what Francois was indicating as well, to maybe look at transport infrastructure, so look more strategically about a city and say, how do we link transport to building design through to lower overheating risk?
Having worked at K previously before joining Arup and doing lots of work with our urban design and landscape and planning teams, it's absolutely vital to link residential developments or refurbishments of existing homes to the wider public realm. Quite how we, like I say, join things up and incentivise that in local planning authorities or strategic sort of citywide planning authorities, I'm not sure. But all my project experience suggests that it's vital to look at the wider public realm as well as the individual building itself. In terms of the sort of paving over of driveways, I mean, there was a big sort of campaign in London a few years ago, sort of highlighting the issue of the loss of green space due to the fact homes, multi-occupancy homes, didn't have much car parking space on the streets, so they were paving over their front gardens to provide extra car parking spaces. Now, that might be a valid sort of functional reason to do that, but again, are there materials and techniques that can be used that mean that hard standing surface allows water to drain through it and maybe allows some greenery or vegetation to be part of that, not just a kind of asphalt kind of square which causes all kinds of problems in terms of temperature and water management.
I think the water management issue is really quite significant, and that's one of the things I picked up at working with United Welsh, that they were aware of that through sustainable urban drainage schemes. That was one thing they were very much aware of. Part of the kind of literature review that I did for my project, I came across a couple of interesting strategies developed in the city of Berlin in Germany, where their planning department operate what they call a biotope area factor, and it looks at the permeability on a scale. I can't remember what the scale is, but they have a classification system for permeability for every piece of urban ground surface that forms part of their development area in central Berlin, and that's becomes part of the planning brief that's developed for development sites within the inner city area. And a similar way, in Seattle, they in North America, they operate, they call it the Seattle Green Factor, and it's a very similar kind of idea, but interestingly, their climate is very similar to South Wales, to Cardiff. They have high levels of rainfall, being where they are on the Pacific, on the edge of the Pacific, and their kind of elevation is very similar to where we are in South Wales. And they've got major problems because of the amount of impermeable surface within the city area, and they've developed this strategic approach which is implemented through the planning system, and they've got quite a lot of information on their website. So if anybody wants to look at that, I could highly recommend it.
Is there anything else to add to that, Nicola?
No, I think my colleagues covered that well.
Okay, are there any final questions or comments people want to make? Okay, well, I think just in summing up, this is almost the tip of the iceberg. I think the point that Francois makes, we have what is the issue here for Wales, what are the risks here for Wales? And as you can see from the final slide, this work is ongoing, and we need your help, because we need sites in Wales as the points say there, comply with building regs 2010, include a variety of house types, make use of innovative passive design strategy, MVHR. Nicola, did you want to add anything to that? Because this is you who's doing this piece of work.
Yeah, so in addition to the overheating project, the Hub is just starting up a project looking at ventilation in homes and how well we are delivering ventilation systems against the design intention. And the Hub ran a big project that many of you may have heard of about looking at the performance gap. So the difference between our goals for energy efficiency in homes compared to sometimes what we finish in the final constructed property. And during that project we conducted, went out to about 22 sites, was it, Rob? And just worked with the site managers and the installers and everybody involved in the construction process to understand what was working well and sometimes what was going wrong. So we're replicating that process for ventilation systems, essentially to try and make sure going forward that we're driving good indoor air quality in airtight, highly energy efficient homes, and making sure essentially that ventilation systems are delivering as expected. On the plus side, the house builders that have been involved in the performance gap project all received really detailed feedback from the site visits and found that invaluable and did a lot to change their processes as a result of that. And I think we want to do the same with the ventilation project. So if we're finding really good practice, we can showcase that and highlight it. If we're finding problems, we can feed that back to house builders and try and learn from looking across properties. So yes, thanks Melissa. We are on the lookout for sites in Wales and Constructing Excellence in Wales is part funding this project, which is great. So yeah, let us know. So there's 2 requests: monitoring data for temperatures and overheating, and sites with a ventilation study.
Okay, thank you very much. Can I ask you please to show your appreciation for our speakers this morning?